Okay, can you see my screen?
Yes, please.
Okay. Last discussion, last class, we talked about Java. What is Java? And then I were able to. We all know that Java is a high-level language, which is basically a high-level language, and which is a platform-independent programming language, which works on principle of object orientation. We break it down into three different parts. We talked about high level. We're able to know that high level is an English language which able to understand by human, and we're able to talk about platform independence of Java, and then object orientation is what we also talk about. But we go into what is this object orientation, and what is this a platform independent of Java? How Java became platform independent? Are we able to know that platform independence of Java will mean the class file of Java can run on any operating system, either Windows, Linux, Mac, etc. So it was on write once, run anywhere principle. I was able to illustrate last section that when you create a file, you write a code, that code will be an extension of that particular file you're creating. We have notes. If you write anything on Notepad, it will save on that particular extension of that particular Notepad, which is text file. If you write anything on PHP, it will text PHP. So there are different text files or different um, platform you're using to run it. So in Java, anything you write in Java will be a extension of that .java files. And I illustrate to you that if I run any particular code on any Windows machine and I compile that code and I want to execute that code in any other operating system. And last week, I'm able to make you understand that when I say OS, OS is equals to platform. Platform is OS, operating system we are using. So I run this code in Windows machine, Windows 11 I'm using. So I run this code in Windows 11, and Java has three processes. We write the code, we compile the code, and we execute the code, which is run the code. So this code was written in Windows and compiled in Windows, but I don't want to execute it in Windows. I want to execute it in Mac operating system or Linux or whatever you use. So now, what is happening here is that the platformity is getting changed. Like I create the file in Windows 11 and compile the file in Windows 11. But now I want to execute the file in Android machine that contains different platforms. So when we say platform independence, it means that we can create Java file on any operating system, and we can execute the same file on any operating system without doing any changes. When we can write any code in any operating system and execute the code in any operating system without doing any changes. That's what we mean by write once, run anywhere principle. So last week, I also tell you that we can see when we go to download Java, we have different flavors. We have different um, packages of Java. Although Java is platform independent, Java for different operating system, when we are going to download our Java, we have different flavors of Java, different packages. And I'd like to let you to, if you go to oracle.com, which is the official site, or you go to, if you say Java, download Java 8 or Java 11, Java 12, we almost have even Java 22 right now. But you go to download Java 8, which is the official website. Okay, this is oracle.com. it will allow you to create an account. You have to create an account so you can able to log in. So when you go to this, you can go to the product, you can see hardware and software. Okay. So I try to elaborate to you what made Java platform independent. Why to extend to able to understand what the platformity of Java is. A cluster of Java can run in any operating system. So why is this Java platform independent? Why is it that we have different packages, in different Java platform, we have different packages. You can see when you go to oracle.com and you click on Java, go to if you create an account here, you go to products and you go to right here, see Java. You can see you see we have Java up to Java 8 is now available. We have different Java that is available right now. But most stable one I'm using right here, I have Java 11, but you can download 8, you can download 11, you can download 12. It has up to this Java 22. So when I go here, let me see, let's go with 8 so you can quickly understand the platformity of Java. So can kind of explain more to you. So let's go to the software, hardware and software, then let's go to download Java. This is Java 22. You see, this will have different for different operating system. We have Linux, we have Mac, we have Windows. I'm using Windows. You go for Windows. If you want to download Java 22, okay. So you can see I want to go for Java 8. I have it on my system, but I just want you to understand. Okay, this 8 right here. So we have 8 for Linux. Okay. If you are, I think I showed you last if you have to know your operating system, right? If you are using what kind of version you have to, what kind of package you have to download, what kind of bits you have to download on your system. Like now I'm using Windows 8. I'm using Windows 64-bit. How do I have to know that this Windows 64-bit? If I click here, you go to properties, then you can see that I'm using on an operating system, I use 64-bit. So if I'm using 64-bit, if you are using 64-bit Windows, you download this one. Go to Windows, you see, we have only 2 packages. Okay. So this is 64-bit. If you're using your Windows is 32-bit, you download 84. Okay, so you go here and download this one and accept the license agreement, then download. I already have it in my system. So you click next, and download Java will be download into your system. So you go to your Google, you say download Java, and you can see we have different packages here. If you're for Windows, these are all these packages. 64-bit, download this one. Okay. You can see we have different packages. In Windows, we have 2 packages, which means although Java is, you can see that, which means that although Java is platform independent, but for different operating systems, for different packages, we have Java packages. Because when we are going to download Java, you can download the Java compatible with your operating system. Okay? Though Java is platform independent, but for different operating system, we have different packages of Java. Okay? So now currently I'm using Windows 11, so that's what I download for this 64 bits. Okay, you go to a PC. If I click on a PC, go to properties, and you can see you have 64 bits. If you are 32 bits, download this one. And when you download this, you can have this exe files to be downloaded on your system, which I have installed as a normal software. Okay, so when you see 84 bits download, that means it's 32 OS. Okay, so after that, you click on these Excel files. It's just something like this. I think I have it on my downloads. Something like this nature. Okay, that's this one. That's Java 8. That's the exe file here, right here. So you click on next, just a normal software, and it will be downloaded on your system. And I always tell you that always know that Java is always installed in your system, in your C drive. You go to a C drive, you can see Java is also installed here. Go to a C drive, go to program files, go to, you see Java is here, okay? When you go to a C drive, you go to program files, you will see Java folder here. Inside the Java folder, you click it, you can see 2 files here. Forget about this one. This one I'm currently using. Forget about this one. There is the Java development people, they try to make GRV inside this or this package, okay? So forget about this one. If you download Java 22, I don't think you'll see these 2 files here. But I want to focus on this Java 8. I just want to understand, I want to make you understand the platformity of Java, okay? So when you click on this, inside this Java, you can see 2 files here. So you can see GRE and JDK. GRE and JDK. So that's what about this topic for today. Can someone tell me what is GRE and what is JDK?
JDK is Java Development Kit.
Mm-hmm.
JRE is Java Runtime Environment.
Okay. Now, before I come to that, in Java, we have 3 steps. We have 3 steps in Java. We write, we run, we write, we compile the code, and we run the code. That's 3 steps in Java. And you can know that, you can see that why you here in this class is that you want to further extend your skills to be an automation engineer. You're migrating from manual testing to be an automation engineer, start writing test scripts, and you need Java for all those things. And what are those automation tools? Selenium, those automation tools where you have to test script, to execute your test script automatically, not using a manual intervention. Okay, make it quick. So you know that be an automation engineer, you will be, your requirement is to do these 3 things. You write, you compile, and you run. So what do I mean by compile? Can someone tell me what I mean by compiling? Compile. In the first intro, I told you what it is. What do you mean by when I say compile? What is compile? To compile.
You're basically changing your soft code into
a bytecode.
A bytecode.
Yes, that's what compilation is. So when we write the code, we write the code in a high-level language. Now, compiling code is writing in dot. I told you when you write, just like you write your code, is in a dot. The extension is .java, right? So when you write that code is, the extension is .java, .java file, which contains English language, English-like language. And the processor, I told you in the last previous first demo intro, I told you that the processor does not understand English language. Okay? Any operating system doesn't understand English language, either your Windows, your Linux, your Mac, and etc. All right? Because processor understands bits. The bits is in what? 0 and what? And 1 language. Yeah, 0 and 1. 0 and 1. So we cannot execute the .java file. We can't execute the English language because it's a high-level language. It's an English language. So we cannot execute that .java file because the processor will not understand what you want to execute and provide the output to your code. You can't do that. So, but to make the programmer life easy, we are using the word high-level language. But ultimately, when you are supposed to execute that code, you have to provide the processor the code that the processor can understand. And the processor only understands binary language. which is 0 and 1. The binary language is 0 and 1. The bytecode is 0 and 1. So you have to provide the processor, the language you could be able to understand. That is the 0 and 1 formats. Okay, so now this is just try to elaborate and tell you how Java is become platform independent. You slightly understand what it means. The class form of Java can run in any operating system with you have to want remains by right one and run anywhere principles. Now, how Java code works? Let me cover this particular slide. How Java code works. Now, I told you basically Java is divided into three parts. We have writes, you have to write the code, compile the code, and you execute the code. Okay, so compilation is what the compiler does. What does compiler does? I told you last time, when we compile the code written by Java.java file, when we compile the code, okay, written by Java, the .java file, written by high-level language, we compile the code using a compiler. Okay, compiler comes in. Compile the code using a compiler. And I want you to understand, compiler does two things. Okay, compiler does two things. What does compiler does? Can anyone tell me?
It converts the code.
Okay, compiler does two things. One, it checks the syntax of
the code.
The code that the programmer has written. And I like to let you know that every programming language has some grammar. Okay? Every program, Chinese has a grammar, English has a grammar, French has a grammar. Okay, so that's what you compile. If when you write your code in a high-level language, compiler comes into the picture. It comes into the picture. You can see the diagram. It comes into the picture and it converts and it checks the syntax of that code that the programmer has written. Now, let me just show you one code here. Don't worry, we're writing this. Don't get it. Don't be scared. Get twisted. This is what compiler does. It compiles the code. It checks the syntax. Okay, see, you can see this thing has written right here. So now written this in a high-level language, right? So you can understand what is string, way, to, automation. These are prints. You know what printing? These are English-like language. So compiler comes into the picture and convert it from what? From high-level language to what? To bytecode. Okay. Now, I'm telling you that what compiler does here, it does two things. It checks the syntax of the code that the programmer has written. I've written this program. So compiler does two things. It checks this syntax of everything. That is it as per the what? The grammar or the syntax of that programming language. If your code is not written as per the grammar or syntax of that programming language, you will not be able to execute that particular code. So that's what compiler does. It comes and checks all these things if there is any error as per the grammar and the syntax of Java language before it executes. That's what compiler does. When you write a code in high-level language, then compiler comes in and do what? And check the syntax as per the grammar. If your code is according to the strict syntax rules of Java, then compiler compiles the code and convert it into what? Bytecode, which is not understandable by human. A little bit today going to be, well, one first introduction, second intro, third intro, I just want to make it. Then after a third intro, I just want to make you to understand these basics. Today going to be theoretical. Then you start seeing the practical aspect of it when you start running into the virtual way. Executing this code, what is class and what is objects and all those stuff. But you need to understand what all this is all about. So compiler comes in and convert into what? High level to bytecode. So it does two things. It checks the syntax of the code that I have written here, and if it's as per the rules and the grammar. Every language has its own grammar. That's what compiler does. It checks and checks the syntax. It's as per strict syntax rules of Java, the compiler compiles into what? Bytecode. So it does two things here. Those are number one. Then two, what does compiler does? To compiler, it will convert the high level language
Bytecode.
into bytecode. But the processor, your processor does not understand bytecode. It only understands machine code. Okay? Your processor does not understand bytecode. It only understands machine code, which is in terms of 0 and 1. So when you execute these files, the interpreter comes into the picture. The interpreter will first convert the bytecode and then provide you the output. That's what you can then see on your system. Any question? Anyone? Any question? How Java code works? When you write your code, compiler comes into the picture. You write your code in high-level language, which is not understood by human. Okay? You write your code which is understood by human, which is English language. So now compiler comes into the picture and compile your code. And it does two things. It checks if your code you have written is as strict syntax rules of Java. Then compiler compiles the code and convert into what? Into bytecode. When you convert into bytecode, processor does not understand bytecode. It only understand machine code. Then interpreter comes into the picture and convert your bytecode into machine code and give you the output. That's how it works. Java has 3 processes. It's not like Python. Python, you just write and run. Well, Java, you have to write compiler. But for Python, it has its own internal compilation happens. But in Java, you have 3 compilation processes. There are 3 execution processes. You write the program, you compile it, then you execute it. So what is your duty as a developer? If I should ask, if you're a developer now, what's a developer develop this code, right? So if you're a developer, what is your duty as a developer? This is just, I'm trying to derive into the platformity of Java being there. So what is your duty as a developer? As a test automation. A developer developed the code, okay? He's one that developed the application, right? Right? So what is your duty as a developer? What does a developer does? Okay, a developer writes, okay, if your duty as a developer, what you do is you write the code, you compile the code, and you run it.
Is it the
Right?
same thing with automation engineer?
Automation also writes the code because I've written this code right now because I want to test what he has written. So I have to have idea of if there is a test case failing here or maybe there is an error right here. Okay, see compilation error. If I write this code, I'll have compilation error. I can't even run it because it's not because Java is not a scripting language. You understand this thing when I start. But if you see if I have to run this thing, you can see Java run as Java application, but because I removed this, I can't run it anymore because you have to start from somewhere. Java is the JVM but I don't want to go into that anyway. Don't worry about it. So you write this code, I have to test it. So I have to write it, I have to run it as Java application. Okay. So your duty as a test automation or a developer, you write the code, you compile the code, and you run it as I do how to run it right now. So that's your duty. Be an automation engineer, be a developer. Of our task is to write the code, compile the code, and then run the code. Okay. And when I was saying something about SDLC, there are three stages of SDLC. We have the planning phase, defining phase, and
Designing,
designing and building,
testing,
testing, and
deployment.
well, deployment. And who does the product? Who does the deployment? The production engineers are called DevOps engineers.
DevOps
Or
engineers.
yeah. So now there are different test environment that testing happens. We have a development environment, testing environment. Um, 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 we have production environment. Okay. So now, what happens on production environment? Okay. What happens in production environment? If our task is to run the code, okay. If your job is to write the code, if your job is to write the code, compile the code, and run the code, so, and we are developing a particular application, and there are different testing environment that this happens. We have development, testing, and production environments. And on production environment, what happens in production environment? You just run the code. What you see in your gmail.com, facebook.com, they are all in production server. So the code is being run. Okay, you will not see it at the back end. If you go to your Google or you go to this, if I should view this page, you can see all these things at the back end. This is written by the back end, but you can't see that. What's your own is just to run it. You click, you go to regions, you go this, you go global. But all those things are at the back end. You can see those are the source code at the back end. It's written by the developer. But you are just running it. Okay. So I don't want to make it more technical for you, but I just want to understand you run your test case at the production server. All these things are in the production server. So if your task is just for you to run, if your job is to write the code, compile the code, and run the code, then you need this JDK on your system. What is that JDK? What is that JDK?
Java Development Kit.
Yes, if your job title, your task day-to-day activity is to write the code, compile the code, and run the code, then you need JDK on your system. So when you're going to download your Java, you download this JDK. You see, when I went to oracle.com, you can see when I go to oracle.com, I'm able to download that. You see Java JDK on my system, right? Product Java JDK. can see different Java packages. You can see Java Development Kit, all right, download. So yeah, you need to download this one, okay? Also on Windows, you download this one. If you're using Mac operating system, any of the system you're using or different packages, you download this thing. But on the client server, okay, on the client, if your job title is just to run the code, like the way I'm just running the code, and just clicking, just to run the code, okay? You just clicking here, you're running the code. So if on the joints, on the client server, if you are to, if your job title is just to run the code, then you need what? JRE. You need just to run the code, you need JRE. What is JRE? Can someone tell me what is JRE?
Runtime environment.
Yes, Java runtime environment. So you need JRE. Just your job title, just to run the code. You need, as a client, you need JRE on your system. But if your task is just to do what? To do these three things, to compile the codes, to write the code, compile the code, then you need JDK on your system. Okay? You need JDK on your system. So what is this JDK? What is different between JDK and GRE? That's diverting into what the platformity of Java is. If I go to this slide, difference between JDK and GRE. Difference between the JDK and GRE. What is this JDK and just this GRE? Now, I want you to listen to me very carefully. Now, when we download Java, okay, we install JDK on our machine, okay? So this is JDK, all right? This is JDK. Okay, this is JDK. When we download Java in our system, we see these two files, right? We see JDK, okay? So if your job title is to run the code, write the code, compile the code, and run the code, you need JDK in your system. So when we download Java, we have JDK installed in our machine automatically. JDK will be installed in your machine automatically, okay? So, and this JDK have two important components. What are those important components? Can someone tell me? What are those important components? We have GRE. JDK has two important components. We have GRE. Okay, inside JDK, we have GRE. As you can see that, if I go to this, say this is JDK, right? Inside JDK, you can see GRE inside JDK. Okay, so JDK has two important components. We have number one, GRE. Number two is some development tools. We have here development tools. And what are those development tools? Any idea, anyone? What are those development tools? The development tools are nothing but what we call debugger and compiler. Debugger and compiler. Those are those development tools. Okay, you have in JDK. JDK have two important components. Inside JDK, you can see that we have GRE, we have some development tools. The development tools are the debugger and the compiler. These tools are important because if we don't have compiler, what will happen? Yes, if we don't have compiler on our machine, we cannot compile our code, right?
Yes.
Okay, so what is debugger? Debugger is a type of compiler. This debugger, okay, is a type of compiler. So the difference between this debugger is a type of compiler, but the main difference between debugger and compiler is that compiler compiles your complete code. The compiler compiles a complete code in a single go. It compiles this thing in a single go. When you compile, what happened? When you compile it, what happened? It converts it to byte code, all right? I repeat, I say debugger is a type of, the difference between this debugger and a compiler is that debugger is a type of compiler that the main difference between the debugger and the compiler is that compiler, you know that compiler will compile your complete code in a single go, and debugger compile the file line by line. Okay, debugger will compile the file line by line. That's what debugger does. One thing about debugger is that when you have an error in this code now, and you want to, maybe error is coming out for someone, you use debugger to find out that error. I'm going to tell you that. I don't want to show you that in this tab, but I'll tell you that in this, how you're able to debug your code. When you have an error, you can debug it to show that this code is coming out in line 13. That's where the code, that's where you're able to execute. Okay, you have a compilation error. What gives you those information? You see, it's debugger. You see this code here. You see the exceptions. Okay, compilation error, exception in thread main, Java, this, that. It was a compilation. You see that error, problem string cannot be resolved in type, string contains string, this is, say inline what? 13. So that's what debugger does. Okay, we want to debug your code. Okay, so debugger is a type of compiler, but the main difference between debugger and compiler is that compiler compiles your complete code in a single go, and convert into bytecode, okay? And debugger compiles the file line by line. That is, debugger is mainly for debugging your code. Let's say we are getting some errors. I showed to you, we're getting some error and we don't know why we are getting errors. If we want to execute the code line by line, if we want to see which line the error occurs, then we have to use debugger. All right, so otherwise we have to use compiler. So JDK contains two important components. What are those important components?
GRE
and development tools. And development tools are what the debugger and the compiler. And now inside GRE, inside this GRE, all right, inside this GRE, inside this GRE, inside this GRE, now inside this GRE, we have two important components inside GRE. The first and most very important component is what we call the, have anyone heard anything about called Nick, do you know anything inside the GRE? Very important component inside GRE. we have the JVM, which is a very, very important component inside GA. We have the JVM. JVM is nothing but,
Java Visual Machine.
yes, it's called, what is that JVM? JVM is Java Visual Machine. Okay. Why the second component is what we called, I'm going to tell you what JVM is in detail, but the second component inside JRE is what we called what? Some important libraries. Some important libraries. That's another thing. The other thing inside this GRE. We have JVM, we have some important library. And those important libraries is nothing but jar files. Jar files. That's what is inside this GRE. GRE has two components inside GRE. We have the JVM and some important libraries, which occupy, what are those important libraries? We have the jar files. You got to know what Java is. Like, they want to tell you high level, like this now. This, if I were to write let me do something like this. When I say system dots, you can see that all these things. If I don't have jar files in my GRE to run this thing, this thing won't populate. System dot out dots. You see, all these are jar files that populate all these things. Okay. Okay, so these are what jar files is, but you understand that later on. So just on a high level, what you just understand that JDK has two important components. We have the GRE and we have some development tools. Our development tools are the debugger and the compiler. And inside GRE, the Java runtime environment, we have JVM and very, very important components there, JVM, okay? JVM is very important inside GRE. And also we have some important libraries, which are nothing but the jar files. Okay. Any question, guys? I will tell you what JVM is in detail. Don't worry about it. I will tell you what JVM is. Okay. So GRE has some important component in GRE. The first most common component is what we call the JVM, which is Java Virtual Machine. While the second important component is the what? Some important libraries. And that is nothing but jar files. Okay. Some important libraries. So I will tell you what JVM is. So the job to execute a file is of GRE. Okay. The job to execute a file is of GRE. Okay. Like, you want to execute any file here is of GRE. Let me show it to the picture. You see, GRE comes into the picture. This interpreter is part of GRE, but I'll let you understand that. So just listen to me very carefully. The job to execute a file is of GRE, all right? So it is the responsibility of GRE to execute the file. When we compile the code, compiler comes into the picture. As I told you, it comes into the picture, into the scene, and compiles the code. When we run the code, GRE comes into the picture, and with the help of JVM, okay, it executes the code. So this interpreter is part of JVM, okay? So as I said, the GRE comes into the picture because GRE is what is inside JVM inside of the GRE. So that's what I say the job to execute any code is of GRE. What is inside of GRE? JVM and all those pattern tools there. So JVM inside of GRE. And with the help of interpreter, which is interpreter is also part of the JVM. So when we run the code, GRE comes into the picture, and with the help of JVM, it execute the code. Okay, Java JVM is Java Virtual Machine, which creates the virtual machine. We convert the bytecode into the machine code, and then provides the output inside JVM. Okay, inside this JVM, there is one important company which is called interpreter. All right. The help of interpreter, what JVM does, it converts bytecode into machine code. So interpreter with the help of JVM with the help of interpreter gives you what the output, what you're seeing here. Any question? It's just going to be theoretical, but we're going to start doing the practical. It also make you understand this very, very clearly. If we have any question?
Please, can you repeat the explanation for the JVM again with respect to interpreter, then bringing out the output? Please, can you just repeat it again?
Okay. You see, Java has JDK has two components. We have a JDK, and inside JDK, as you can see, when you go to download your Java, you see JDK. Okay, inside JDK, you can see you have GRE. Okay, so that's what I make you understand here that JDK we have GRE, and inside JDK we have GRE, and we also some development tools. Development tools are the debugger and the compiler. Why the compiler is that? Why, if you don't have the compiler, we cannot compile. We know what compiler does. And debugger is the part of compiler also. Yes. The difference between debugger is that compiler will compile your complete code, but debugger will able to do what? To execute the code line by line. Okay. In case you have any error in your code, debugger that's what you're going to find out. You're going to debug your code. So that's what's the difference between debugger. So those are those development tools. Now, coming to GRE now, GRE have two important components inside GRE. Now we have the JVM, which is the most and important part of what GRE. And number two, GRE has JVM, all right? We have inside GRE, we have JVM, which is very, very important. And secondly, we have some important libraries that is in the form of .java, which I don't show you, but you understand what Java, just understand what this GRE contains. Those important components is JVM, which is very important, and some important libraries, okay, which is nothing but .java. Now, the duty to execute a code is of the GRE. And JVM is part of that GRE, okay? So when you write your code, you write your code in high-level language. Now, when you compile the code using a compiler, okay? And compiler compiles it to high-level language to a bytecode. Then the processor doesn't understand your bytecode, you understand machine code, which is 0 and 1. Then the interpreter JVM comes into the picture. Okay, all these things are the works of executing their particular code is the works of all these things, all these people here, these guys here. JVM is said GRE, and the interpreter is inside of JVM, it's part of JVM. It interprets that particular language and gives you that output. So when you compile your code, then bytecode, then GRE, to execute that code is work is the duty of the GRE. GRE comes into the picture, which is that JVM, okay? We have for this JVM. JVM, we then convert it to byte code to a machine code. Then with the help of interpreter, they see the output. It provides you the output. Inside the JVM, there is one important component which is called interpreter. The help of the interpreter, what JVM does, it first convert bytecode into the what? Into machine code, with the help of what? Interpreter. The interpreter is a part of JVM. They are all executing that particular code. So when you, for that particular code, which is in bytecode, okay, the JVM will then convert it from bytecode to machine code with the help of the interpreter and gives you the output.
Okay.
It provides you the output. So in summary, all right, I want you to understand this in summary. Now look at these slides very carefully, all right, how Java code was. In summary, how the Java code was, we have to write the codes. Whenever we write the codes, that code should be in the Java file, okay, extension.java. Then we have to compile the code. So when we compile the code using compiler, the compiler will convert the .java file. This, you can see the diagram here. The compiler will convert the .java files into .class file. It will not convert .java file into .class file. It will create one new .class file. This is going to be trivial right now, but we start doing it practically. You understand this? Okay. It will have one class file being created, which is .class file. The class file will contain byte code. And when we run the code, we never execute this .java file. Java files are not executable. Hope you get my point. The compiler will convert the .java file into .class file. It will not convert the .java into .class file. It will create one new .class file. .class file will convert, will contain this. .class file is one that contains this bytecode. And when we run the bytecode, we never execute .java file. We always execute .class file. And when we execute .class file, JVM will come into the picture. And with the help of interpreter, it will first convert the bytecode into machine code, which is understandable by the machine, and it will be executed by the processor. And finally, we get the output. Any confusion?
Can you hear me?
Any doubts?
Can you hear me?
Yes.
Okay. So when you're talking about the compiler, so does it mean that when we're compiling in JRE? Is that what that helps read the code?
Yes. When you write your code, you write your code in high-level language, right? Which is understood by human. Okay. So when you compile your code, compiler comes to the picture. But all these things is doing at the back end. Like what I'm doing now. You don't know what's going on. I'm writing these things. Okay. I'm trying to compile. This compilation has already happened at the back end, but don't worry about it. You should understand that. So when you write your code, which is understood by human, you understand this print, all those things, you understand all those stuff. When you compile your code, compiler comes into the picture. Okay. So now, when you compile your code, compiler comes into the picture and convert it into what? There's a new class file that's going to be reformed, okay? Which is what they call the class file. That you know, when I told you before, I told you that when you compile your code in compiler compiles it into what? Convert it to byte code. That byte code is that classifier you are seeing here. It's going to be a bit theoretical, but when it's doing practical, you understand much better. You write your code in a high-level language and you compile it. Compiler come into the picture. Compiler will convert it to byte code, okay? And your processor does not understand byte code, you understand machine code. So when compiler compiles this code into byte code, this is what you're going to see. That is the class file. Because Java files is not executable. It's only class file that is executable. Compiler does these things. It comes into the picture and convert your high-level language into bytecode. Bytecode is this .class file you are seeing that here. And that bytecode is in form of .class file. Because Java file is not executable, it is class file that is executable. And with the help of JVM now, with the help of JVM, okay, this JVM, all these people here, these guys here, that won't execute your code, the duty to execute your code is of GRE. These are all his members. JVM, interpreter inside of this JVM to interpret that particular code and everything, okay? They are these duties. So just know that back of your mind that to execute your code is of these people here, GRE, JVM, whatever it is, or whatever you want to call it, GRE execute, JVM, all these things are the one that execute all these things. Because now you compile your codes, compiler comes into the picture, convert it into bytecode, and that bytecode is what they call that .class files. Because Java file is not executable. It's class file that's executable. I hope when you start doing it in theoretical, in practical, you know what I'm talking about. You do it practically. You see that. I will show it to you that this .java file is not executable. It's class file that is executable. So when you compile your code, compiler comes into the picture and convert it into bytecode. And that bytecode is nothing but .class file, which is executable. Okay? And your processor doesn't understand this bytecode. Then JVM, which is part of this interpreter, which is a part of JVM or GRE, to execute your code is of GRE, okay? Java Runtime Environment. And what are those components of Java GRE is what? JVM. Inside JVM, you see interpreter is part of that JVM, okay? So they guys come into here and convert your bytecode into machine code. And with the help of interpreter, then it gives you the output. After converting your code into bytecode, the interpreter executes the bytecode line by line. Any questions, Mr. Chairman?
I mean, I'm okay for now.
There is no question, but
Because you write your codes, okay, English-like language, and you compile it. Compiler then come into the picture. The compiler will compile it into bytecode. And now I'm just telling you that that bytecode that that compiler compiles is nothing but the class file, because the class file is executable files. The Java file is not executable. And I'm saying again, when you start doing practically by next section, next topic, next class, you start understanding what I'm talking about.
Yeah.
Because the processor does not understand bytecode. That's why JVM comes into the picture, okay, and convert it into what? Into machine code, machine language. okay, with your processor understand machine language, which is in form of 0 and 1, okay, with the help of interpreter, then gives you the output. It provides you the output. So now we install Java in our system, okay? When we install Java in our system, and inside program files, we can see these two files. Inside program files, we can see these two files, right? As I told you, inside program files, you see these two files. Inside Java folder, we have two files. We have JDK and we have GRE. Now, next is to set the path of Java in our system. Okay, the next point now is to set the path of Java in our system, in our computer. My time is fast spent. Can you give me like 5 more minutes? I just want to have just 1 hour class. We continue tomorrow.
Sure. So
Should we
tomorrow,
continue 5 minutes? Yes.
We'll
Because I want you
continue
to
tomorrow, right?
understand. Yes, I want you to understand this thing very clearly. And also, how
So
to
we can continue
after.
tomorrow, right?
Yes.
Okay.
Can you give me 5 more minutes? Or we continue tomorrow?
Yes, you have 5 more minutes if you want. For
Okay, let's
me,
continue.
yeah, that's fine. That's fine. Fine.
It's just the installation of Java. Just installation of Java. Okay. Oh, that's going to take me some time again. Let's continue tomorrow because just because this one is going to take me some little time to like complete. So because it's just installation of Java. You download this Java. And when you download this Java, I told you that when you go to your program files, you're going to see tool folder, JDK, and GRE. So now the next step is to set the path of JDK. Set the path of JDK in your computer, in your system, okay? Your system environment, okay? This is very important part, unless you will not be able to use the Java you have installed. You have to set the path of JDK. So go inside this JDK folder, So go inside the JDK folder and copy this part. Right. Yeah, go inside the JDK folder and copy these parts. Okay, say copy, then go to, okay, I will paste it here. See the same thing I paste. Okay, paste here, the same thing. Okay, that's Java 8, all right? So you paste it here and just save it somewhere, right? Just save it somewhere, okay? So you paste it, you have to configure the part of JDK, or there's the Java you install your system will not work. So save it somewhere, okay? So you can see that inside JDK, we have your Java folder. Inside Java folder, you have your program files. Inside the program file, you have your C drive. Okay? Hope you understand this. Inside JDK, we have your JDK is inside your Java folder. Inside Java folder, you have your program files. Inside your program file, we have your C drive. What I mean is I see this is this. C drive, I say Java, when you download your Java, okay? Try and download it today. Then we start doing the configuration tomorrow. I want to end the class for today so that we'll not get it more plenty, okay? So when you download your Java, I told you that your Java is in your C drive. Inside your C drive is in your program file. Inside your program file is your Java. Then inside your JDK is in your what? Your JDK folder. Okay. So that's what I'm saying right here. Okay. JDK is in your Java folder. Your Java folder is your program files. Then is your program file is your C drive. Okay. // right? Java install your system, your C drive. You can see your JDK is in your Java folder. Your Java folder is your program files, and your program file is in your C drive. Try and download it today. Then tomorrow we do this configuration of your Java, so you can be able to use your Java. And all this boils down to what platformity of Java. I will explain why Java became platform independent. All this boils down from your downloading of your Java. All right. So I hope you didn't get bored today. You're able to grab something today and understand is that when you compile your file in high-level language, compiler comes into the picture. When compiler comes into the picture, it converts these things you have written in high-level language to bytecode. Your processor does not understand bytecode. You understand machine code, which is form of 0 and 1. Okay, so when compiler compiles these codes, it has one file that is being created. It creates a new file which is called the class file. But the class file is executable. Okay, then that is that bytecode. Okay, then it's not understood by the processor. I mean, the processor doesn't understand the bytecode, it understands machine code. Then what happens is that JVM comes into the picture. With the help of interpreter, it converts it from this bytecode to machine code. Then the help of the interpreter, with the side of the JVM, it gives you your desired output, what you can see on our system or VRON. Any
Hi, Stanley.
question? Yes, ma'am.
I don't have a question. I just have a suggestion. If I'm just wondering because I know Corriday, I can notice that it's a bit confusing. I don't know if I can share my notes maybe on the platform later if you want to just read, and I think that simplifies it a little bit in a way that you'll be able to understand it better
Okay,
before the next class.
Okay, your notes, your written notes.
Yes, my notes, yes.
Okay, I will share the screen.
No, it doesn't have to be right now because we're
Okay, yes. I mean, yes. I'm talking about the next class, yes.
yes. I'll just put it together, then I'll share it with Corriday if he wants to read it, or maybe everyone, or maybe on WhatsApp or something. I can always share it, so you can just go through it. Like it's much more easier the way I put it, and maybe you will understand it better.
Okay.
You guys can even share a platform where you can discuss, and anybody has any.
Yeah, I'll be glad to have it.
No problem.
Thank you so much.
You're welcome.
Yeah, anyone has any questions? Choma, do you have any questions? Okay.
No, I don't have any question. I don't know. Tomorrow, what time is the class going to be? Because I'm going to be traveling.
Tomorrow, maybe same time. What time, you guys, what time do you think we'll be free for? Want to make it Saturday, or you want to make it if it's weekend? Because I want to have more time to make sure that this is being well explained before I go into theoretical, practical part of it.
Yeah, tomorrow's Friday. We might make it earlier than 12, maybe like 11.
Yeah.
If you make it by 11, some of us will just be coming from work.
Yes.
Yeah, it's going to affect us. And this kind of lecture, you don't need to listen to it when you're in the car. It's not really good. Please.
Okay. Yeah, you say some of us.
Please. Maybe I will limit myself rather. So.
Okay.
I will be on the road, so I'm not sure I'll be able to.
Okay, I'll see.
On the computer.
Okay. You're going to understand everything. It's just like, just watch the video and do some little bits. Just understand the concept. Understand the concept, how it works, how Java code works. Just understand the concept. Then you start doing the practical, understand it more. I'll let you know for the next class, but I want just for you to, if you have to just download the Java, then you start from there. I have to configure your part of JDK because you are running it. Okay. Yeah, you are writing the code, you are compiling the code, you are running it. So you need JDK in your system. Okay, so you need JDK, Java Development Kit. So inside JDK, you have GRE. So GRE helps you to execute that code. So inside GRE, there's important, very essential, important component, which is JVM, and some important libraries. nothing but the jar files, which you can see here. So JVM helps you to do the execution. The most point of is to execute this code is of JVM with the help of the interpreter, because JVM is inside the interpreter. Okay. So I will close it for today.